5511. Okay, so 5511 is one of our original devices, right? P-hemped, yes, P-hemped. We had to do several design spins on it because it's somewhat of a, well, as we'll discuss in a minute, it's somewhat of a Cadillac performer. But when you have a performer like that, it took us a long time to stabilize it. You remember that? So what it's grown into is, gosh, I'll say general purpose, but infrastructure applications, wide, very varied applications from 400 megahertz to 6 gigahertz. Even actually, we have a few above that, right? It goes to 9 in some cases, and it has a healthy amount of gain, very good linearity, handles wide waveforms. It can accommodate a wide bandwidth waveform and maintain its linearity. So has a good noise figure if you match it that way. You can run it at elevated voltage for a higher compression point, and I've tuned it anywhere from 400 megahertz to 9 gigahertz. It is one of our most versatile PAs, and it's going to continue. But we've been selling it for years, and it's going to continue because I just did another application for a guy, wanted to run it from we got two applications. One, he wanted to run it from 1 gigahertz to 2.5, which is fairly broadband. Tuned it up, ran the data for him, looked good. He also wanted to, his other big thing was he had 1.8 volt logic on his V-enable that he wanted to use. So his original question was, he asked me, when does it turn on? How low of a V-enable can I use? So I had to sweep that for him. But in order to say it's all going to work, I figured I might as well match it up for him, make sure the whole thing works. So I did that for him and just communicated, and everything's good. So that is one of our best general purpose linear amplifiers that can go anywhere. It's one of our best parts. We know we can run it at 3.3. It's got a cascode. It'll handle 3.3. You can probably go lower. So 3.3 to 8 is where I run it. We've recently run some experiments as a driver at 10, where we run our V bias pin down at 5, and it's going to take some. We're going to have to confirm it with more use, but let's just say you can run it anywhere from 3.3 to 10. And at 10 volts, you can get a compression point over a watt, right? And and it has excellent IP3 and ACLR, so its new home maybe is as a GAN driver, right? That's just going to be more. So it just adds to the list of things it can do. So the key pins on the device are the non-conventional pins, right? You have a pin 14 we called the bias ground leg. It was we originally collaborated on it when we learned that we could oftentimes put a low frequency shunt resonator on the input pin and to provide a termination for low frequency intermod beats, and in that way linearize the PA. You said, well, I can kind of bring that inside and put on the gate of the FET. Not literally hanging off the gate, but almost. And what we found was Does it work as good as putting it at the input pin? Not quite. Does it work good enough to influence your linearity? It does. So pin 14 is a termination that you can impact linearity. The only downside of that is, depending on where you're at, what frequency you're at, it's an iterative, experimental. What's the word for it? Empirical. It is an empirical exercise in finding the correct termination, right? Sometimes there's no rhyme or reason, but I've done it for so long that I have drafted presentations to give to my customers. I just put one out, and Hanson's using it. A lot of people are using it. That discusses pin 14 and pin 12, the bias pin. It's a little more simpler. There's a resistor outside of it, and you can oftentimes find an optimal value for that resistor for linearity. If all you want is high saturated output power, you make that resistor 0. So those two pins, pin 14 and pin 12, bias ground leg and V bias for linearization. You know, really, what it comes down to is, the best thing is for the customer to understand what he needs and ask intelligent questions, and then we'll give him the answer, because it's going to be a function of frequency band. It's going to be a function of what output power you want to run at, what type of linear you need, and the answers for all that come over a long period of time right here on the bench, and that's what we're here for. So I can make presentations and give guidance as to what the functions are, and that'll be helpful. But really, that's where we come in. This eval board is tuned for your application, and everything matters. Assume everything matters, right? Assume I put it there for a reason. Yep. So that's the best thing. So sometimes the result of an ingenious design is it's using it isn't necessarily cut and dried, right? It's not cut and dried. If you want performance, you're going to have some intricacies, right? It's the way it goes. It's just the way it is. You want something simple, that's fine too, but it's only going to do so much for you. Case in point, we hear about everybody's integrating their modules, and they're integrating their modules, and so has an integrated module, and it only costs 45 cents. Well, that's great, but you know what? It's only going to do so good, right? If everybody could integrate modules that murdered the specs, we'd all be in trouble. But they can't. They can't. Sometimes, so there's a home for discretes that do really good. There are. Yeah, there always will be, I think. Right? So that's what we do. So we have an EBB now where we're, I'm not gonna say we're experts, but we've combined a lot of amplifiers in hybrid couplers to double everything. Ideally, double the power, double the IP3, double the compression point in IP3, ideally. Realistically, instead of getting 3 dB for a 3 dB improvement, you get 2.5. But that matters to a lot of customers, and so that extra 2.5 dB of power matters. So a lot of them are willing to do it. I have a customer, and now this is coming to mind. I have a customer that we're doing it with 5511 for obvious reasons. I had a customer I was just on the phone with the other day who did it with GRF5611 to get a boatload of power, to get a lot of power. But more importantly, he has customers that have return loss specs that require he use the hybrid couplers. So if you have an output load line that's matched and has an ugly return loss, put two of them inside hybrids, you get a great return loss, and he does it for that reason. You usually figure they're doing it because they want twice the power. Not always. He wanted great return losses and plenty of power, so that's why he did it. And that's great for us because we get two designed in, you know. So, and we had designed that board for 5511 back several years ago, and had to go through a few iterations because layout's complicated, and we had to mount those hybrid couplers correctly. I believe we ended up going with the manufacturer's layout and to get them to behave right at 5 gigahertz. And so it's a great solution, but it's somewhat challenging. Got to get the layout right. And I'm not really a layout expert. I'm okay with layout.
Thank you so much for watching. If you'd like more information, please email us at sales@guerrilla-rf.com. And don't forget to subscribe to our channel for more content from Guerrilla RF.